Hey everyone, so in today's GFG POTD, we have to solve a problem, delete middle of linked list. So as a question given here, given a singly linked list, delete middle of the linked list. For example, if given linked list is 1, 2, 3, 4, 5, then linked list should be modified to 1, 2, 4, 5. Okay. If they are even nodes, then there would be two middle nodes. We need to delete the second middle element. For example, if given linked list is 1, 2, 3, 4, 5, 6, then it should be modified to 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6. Okay. If the input linked list has a single node, then it should return null. Okay. So basically in this problem, it is saying that we have a list of linked list, and this list maybe either like even number or like odd. So if we have a odd number of list in like linked list, so we can simply remove our middle element. Okay, but in the case of even element, like uh, I can explain it here using example here. So this is actually a list inside the linked list, and these are actually even number of list. So here there are 6 elements. So we can say here, um, if you're going to try to find about the middle element in this list, so we get like 6 and 7 as a middle element. So we have to take the second element as the middle list, and we have to delete it from the list. Similarly, if we're talking about this example, so here we have odd number of list, so we can simply find our middle element, and we can simply remove it from the list and make a connections between like this thing to this. Okay, so in case of odd, it is easy to understand, but in it is also easy to understand in even also, but here we have to take only the second element from the middle element. Okay, in case of even, so we are going to solve this problem using 2 pointers. As the question given here, we have to solve this problem using 2 pointers, and we have to solve this problem with an expected time complexity of order of n and expected auxiliary space of order of 1. So basically what I can do here, first of all, as the question also given here, that is if we have like a single element, or like if we don't have an element, then we have to simply return null. So first of all, in my step first, what I can do here, as the question given here, if we don't have an element, like we can say that if my list is completely empty, then we can say that we have to return null. So we can say that here, that is if my head is equal to null, or like we can say that if my head next is equal to null, then I need to return null. This is my first step, as it is already given in the question also. Okay, and now for solving this problem, what I can do here, I have to take a better approach, like I have to solve using 2 pointers. Okay, so here I'm going to take a 2 pointer. So first I will take a node star. Let's say I'm saying my pointer name is like slow pointer. Okay, which is currently at my head position. Okay, and similarly I have to create another pointer. This is like fast, and giving a name as fast for my this node, and this is also standing on node. Now what are the working of both these, we can say that pointer, let's understand. So here I'm actually saying that I have declared like my fast pointer and like my slow pointer. So basically we can solve this problem by using only these two pointers. Using these 2 pointers only, these 2 pointers are only the things through which we can solve this problem very easily. Let's say I'm saying my first pointer here, and my second pointer is also at my head node, right? This is my second pointer, or we can first pointer and slow pointer. So this is my slow pointer, this is my slow pointer, and this is my fast pointer. Both are actually at my head position. So what I am going to explain here, basically my fast pointer is actually moving and traversing through a complete list using, we can say that it completely, by using we can say that is it is moving through 2 axis speed. That means like fast is traversing next to next, okay, and slow is traversing by one step. So in simple words, we can say that it is moving with like two steps. We can say that it is moving like two steps, and by this approach we can easily explain here that suppose it is moving two steps, and slow pointer is moving by using like my one step. So this is the only approach which actually satisfies both the condition for my either even number of like list or like odd number of list. Okay, so how it is going to how actually it works, I'm going to explain it one by one. So let's understand. So first of all, I'm going to make a code here. So first of all, I can also make another node which is basically used to store um, my that middle element. Okay, so for that I am saying that is node pointer previous, which basically text which is also staying at my head position. Now I need to traverse through the list and find the middle element middle element. Basically my previous element or previous node are basically used to find the middle element. Okay, so now I have to traverse one by one. So while if my fast while first pointer is not equal to null and fast next is not equal to null, this statement actually saying that we need to traverse a complete list until my fast will not become null, because if we are looking at this expression, then this actually satisfies for my even number of list and this satisfies for my odd number of list. Now I'm going to explain it here. Like I'm saying that is I have to traverse a complete list. I have to traverse my complete list. Like if I'm saying that is this is my fast here, and this is my fast, and if I'm going to traverse it here, so I need to traverse until my fast will not become null. So as I know very well, when my fast is actually when my fast is actually on this place, then my slow is also on this place. Okay, actually on my fast, when my fast is actually arriving at this position, my slow is on this position, because my slow is actually moving by step 1, whereas my fast is moving by step 2. Now similarly after 2 steps it is on this position, my fast is on this position, and my second is on and my slow is on this position, because it is moving only 1 steps. Okay, now again, now it is fast in the as I've given here the things, as I've given here the condition, that is fast next is not equal to null. That means when my fast is actually arriving here, when my fast is actually, I can say that here, so when my fast is actually on this position, then for that I'm using this condition here. Okay, then and similarly if we are talking about from this example, when my fast is on this position, then my slow is on this position, and when my fast is in the last position like here, then I'm getting a slow position as this position, which is my middle element. So we can easily to find in the even. Similarly in the case of even number of elements, whenever I'm here, I am actually in this position, but when I am getting on this position, I will get like this middle position, and simply I can remove it from the list. So let's understand this thing. Now I can say here, like as I defined the previous node, so inside previous I have to store my like slow pointer, because we know very well, as I understand from this example here, because slow pointer is actually those pointers which are actually pointing to the middle element. So that's why we actually storing in the previous, so that we can simply remove by using previous node. Okay, so once we have done these things, now I'm going to define like what slow will do. Slow is actually slow is actually traversing the list by one step. So it is actually traversing by one step. Okay, similarly if I talk about fast, so fast is actually traversing by two steps. That means fast next. Okay, that means it is traversing by two steps. Alright, yeah. Once it will be traversing, we can say that whenever it will reach at the final position, that means whenever my final or my fast pointer is actually achieved at the or arrived at the null pointer, that means the final node, that means we can give a idea that our slow pointers is actually on the middle element, as we have seen from these two examples, that if my fast position is starting from here, and if it is actually going from by if it is tracing by two position like this and like by this, then our middle element is on this position by, or we can say that my slow pointer is actually on this pointer. So we can simply remove this one. And similarly, as I've also discussed in this example also, that if my first pointer is moving by like this and like this, then my slow point is actually on this pointer. Okay, so we can simply remove it. So yeah, that's all. That means currently I am standing on, that means I can say that here currently I am staying currently we can say that currently my slow pointer is staying at middle element. So what I can do here, I can simply make previous next. Okay, that means I'm completely we can say that delete this particular element and move forward and make a connection to the next node. So delete previous next is equal to, we can say that it is slow next, and finally we can return our head. Okay, let's check the question. Now we got our output. So yeah, that's all for the today. Thanks for watching.